Here we are in Unit 5, Lesson 3. So let's jump on in, representing exponential growth. So exponent rules, okay, just a little review. Rewrite each expression as a power of 2. So we want it to be 2 to some power, all right? So when I'm multiplying, I add my exponents. So 3 plus 4 is 7. Here I'm multiplying, so I add my exponents. 5 plus 1 is 6. When there isn't a power written there, you assume it's a 1. Now when I'm dividing, I subtract my exponents. That'd be 2 to the 10 minus 7, which is 2 to the third power. And then here's a 1. I'm dividing, so I subtract my exponents again. 9 minus 1 is 2 to the 8th. All right? Okay. Now, what does x to the 0 mean? Well, I think you've learned in the past, anything, any number at all raised to the 0 power is always 1. I could have 1,000,000 raised to the 0 power and I would get 1. All right, so complete the table. Take advantage of any patterns you notice. So here we have, if x is 4, 3 to the x power is 81. Okay. 3 to the third power is 27. 3 to the second power is 9. 3 to the first power is 3. So 3 to the 0 power is 1. Okay, I don't see a pattern there. I just memorized it. We have to start out with something though. So when I raise it to the 0 power, it's just my beginning base of 1. What we have here is our function 1 times 3 to the x. But when x is 0, it's just 1. Here's some equations. Find the solution to each equation using what you know about exponent rules. So here, 9 to the what power times 9 to the 7 equals 9 to the 7. Well, I haven't changed anything, so 9 to the 0 power times 9 to the 7th power equals 9 to the 0 plus 7, or 9 to the 7. All right, now I'm dividing. I said when we divide, we subtract. So 12 minus question mark equals, well, question mark has to be 0. Okay, so if this were 9 to the 12 over 9 to the 0, that's the same as 9 to the 12 minus 0, which is 9 to the 12th. So what is the value of 5 raised to the 0? 1. And 2 raised to the 0. 1. 1,000,000 raised to the 0. 1 pi raised to the 0. 1. Anything raised to the 0 power is in fact 1. All right, are you ready for more? We know, for example, that 2 plus 3 plus 5 equals 2 plus 3 plus 5. Okay, it's our associative rule of addition. And it's just grouping, so I'm just grouping it in different ways. This grouping with parentheses does not affect the value of the expression. All right, is this true for exponents? So go ahead and dive into that, and I'll give you a bonus point on the next quiz if you email me. Oh goodness, be right back. So annoying. Multiplying microbes, and that's also annoying. In a biology lab, 500 bacteria reproduce by splitting. Every hour, on the hour, each bacterium splits into 2 bacterium. Write an expression to show how to find the number of bacterium after each hour listed in the table. Okay, so we're trying to come up with that expression, which we didn't do in the first lesson, because I told you we would get to it. All right, so we have our number of bacterium is going to be our initial amount times, let's see, splits into 2. 2 to the time. Okay, so that's what's happening. This is my initial. And just like that, we have an expression, and time is in the exponent spot. So write an equation, oops, I'm sorry. I did not do part A correctly. I should have done this. Okay, I was not reading it correctly. Right? Now I need 6 2's. Or 500 times 2 to the t. So this would be the same as 2 to the 6th. This would be the same as 500 times 2 to the 3rd power. Same as 500 times 2 squared. 500 times 2 to the 1st power. 500 times 2 to the 0 power. All right? So there we are. Use your equation to find n when t is 0. I just did 500 times 2 to the 0 power. 2 to the 0 power is 1. So my answer is 500. That means in this situation that my initial amount of bacteria is 500. In a different biology lab, a population of single-cell parasites also reproduces hourly. An equation which gives the number of parasites P after T hours is here. Explain what the numbers 100 and 300 mean in this situation. Well, 100 is my initial amount. Of parasites at time 0. And the 3 means that every hour it is tripling. Sorry. Okay, I have to go do morning duty. I will be right back to finish 3.4. Alright, so refer back to your work in the table, the previous task. Use that information and the given coordinate planes to graph the following. Graph t, comma n when t is 0, 1, 2, 3, and 4. So we're going up here, right? This is what we're graphing. Okay, so let's see. Get a little bit thicker pen. At time equals 0, we're at 500, right? Sorry, I got distracted. I mean, someone came to my door. So at time equals 1, we're just doubling every day. So we're at 1,000, and we're going to double that, and we're going to double that. See if I can follow that 3 all the way up, and then double that. See why these exponential graphs need such a big vertical axis, right? And then graph t comma p when t is, oh gosh, did I graph the wrong thing? What is t comma p? Is that this one? Oh, I need to look to see what that one is referring to. Oh, that's this one, triples every hour. Sorry. Okay, so we're still starting with 500. Oh no, this one starts with 100. My bad. Let's erase that. So here we're doing P equals 100, 3 to the T. And this was N equals 500 times 2 to the T. Okay, so we start out with 100. 2, 4, 6, 500, 250, so 100 about right down here. And we're going to double that to 200. We're going to double that to 400. We're going to double that to 800. Double that to 1600. We're not doubling, we're tripling. You guys rolling your eyes at me? You should be. So triplet, 300. So 300 tripled, 900, tripled, 2,700, and triple, 8,100. So it surpassed this one by day 4. Cool. Hold on. On the graph of n, where can you see each number that appears in the equation? So on graph n, we see that the vertical intercept is 500 because it's 0, 500. Where would we see the other one though? Yeah. Vertical intercept. The 2 is a doubling. Okay? And then I ran out of room because my pen's too thick. Is the doubling of the initial value. Initial value, which is 500. On the P graph, where can you see each number? So we know that the vertical intercept is 100 because we are 0, 100. And then 3 is the tripling. Initial value. All right, and then you have your summary at the end, which you have in your book. Cool. Okay, these are problems that we always see. Okay, you build your equation, and then by the end you get the equation, right? And then graphing. My initial value, so it's 500, and yeah, we're tripling it. All right, I'm going to log off. Good job.